Yeah, so quickly to some updates. Let me, and it should be visible now. Yeah. Yeah, I got some updates from the work package 3. So this is basically the first demo session that we want to do. So we hopefully to continue these. Is it every more or less 2 months? Every time the 3.1 task is there. And yeah, basically want a quick overview because it's the first one. What we'll do in such a demo, it's based on the Scrum principles. So if anybody is known with the Scrum principles, there's this demo session. It's often every sprint, which would be 2 or 3 weeks, 2 weeks for the DiSSCo team. But yeah, as we're just 1 or 2 developers often, that's a bit too often. So we'll probably do them every other month. Yeah, we'll look at what's new. We'll look forward. We have some discussion, and we already talked about opening it up. So the demo, yeah, it's a technical demonstration. So yeah, we'll focus on the technical details of the implementation of the DiSSCo core platform by the development team, which are usually Sulen, Tom, and myself. Well, Tom is out skiing today or this week, and Sulen is sick. So today you only got me. And we'll aim it at the deliverable, the 3.1 deliverable, which is the deployment of a minimal viable project of the core infrastructure. So that's really where we're trying to have the focus on. We'll probably dip into some side things, something about TETTRIs Marketplace in here as well, which we're working on, but I will try to keep it mainly focused on the DiSSCo core infrastructure. So we'll take a moment to see what we have done in the last, let's say, 2 months now. I've tried to take it from the DiSSCo Transition project kickoff until now. So more or less that time spent. What we'll do in the next more or less 2 months, hopefully. And then we have room for discussion and alignment with the other work packages and the other tasks. So that's the basic setup. And then just as a reminder, I'd like to drill this diagram in there. We have data providers, we have data consumers, we have then human agents. So these are more platforms built on top of the core infrastructure where humans can interact things. So this is actually humans with the graphical user interfaces where they can, do some citizen science platform stuff, or go to discover and annotate specimen, go to Elvis, request clones, those kind of things. Then we have human agents, which I will focus a bit on today as well, which are more services that run on top of the platform, which are machines adding information to the specimen. And then we got the core infrastructure, which, collecting, harmonization, meeting of PIDs, versioning. We got all extending, linking, data exposure, and this is the blue stuff is more or less where this demo will be about. So it will grab mostly the DiSSCo core infrastructure. We have some demo machine annotation services, mainly to just show how it would work. And then we have Discover, which is the human interface, which is a bit nicer to show than only API calls. And then, yeah, what's new? So this is a long list, and I will try to keep the slides to a minimum. The first point that I would like to show is that we're exposing our JSON schemas. So in the background, we have lots of JSON schemas for the data models, and we're now exposing these through schemas.DiSSCo.tech. So you can actually go here, and then it's a really basic Nginx, just serving static files. And these static files are basically just our GitHub repo files. And we created JSON schemas, for example, for the digital specimen. We have a digital specimen here. And it's just a long list of all the things all the properties of digital specimen, which are required, of course, and some description. If we borrow them from Darwin Core, we point to the Darwin Core term. And you can move through this for the identification and see how the identifications is set up. And yeah, we try to versionize these. So this is the 0.1 version. We're still in testing. And we try to put everything we have, put them in JSON schemas, and we actually use those JSON schemas to also generate code ourselves. So these are the schemas that we actually use for the actual objects or cells, and also things like the FDO profiles are here, which is a bit longer list on how the FDO profiles and the objects for those work. Tombstone request. There's some that are mostly internal, so we're still thinking on how to separate these. Often when it's dash request, those are internal, but for the mapping, yeah, the FDO still really small. And for annotations, we also got, I think, 2 internal ones, and this is then the annotation data model for the external ones. Yeah, so we try to get a bit more open and clear on what the current states of the models is, and this is completely based on the OpenDS data model. It's basically the same structure as we have here. So there's an Nginx here and a Docker, and if things change, we build a new image which we publish. So it's as basic as possible, but an easy way to just serve all the JSON schemas. Yeah, I think that was the first thing I want to show. Then the second thing is that we deployed a new version of the Open Digital Specimen Annotations to the sandbox environment. So the sandbox environment is basically our acceptance environment. So we have a dev.DiSSCo.tech, that's where we test on daily and we have daily changes. And then the sandbox is a bit more stable. We try to do release as well. You still need a good cadence, but we'll probably also be every 2 months. See if we can align those with the demos as well. And the things I show are mostly available on acceptance. So that would be the idea. And yeah, for this demo, I want to see if we can do a bit deeper dive into the machine annotation services. So with the DiSSCo Futures kickoff, Tom showed the front end and how you can make annotations in the front end. But here I want to show a bit of the machine annotation stuff, so which is a bit more technical, but might be a bit more interesting for this group. So we have, next to the sandbox environment, we also have something called the orchestration.DiSSCo.tech. And these are kind of orchestration services in the backend. For example, we have something called source systems, which is basically where we collect the data. So you can actually add a new system and say, well, this is the name and this is the endpoint where you need to collect either DiSSCo archive or a Baucase instance. And a certain mapping, so maybe too deep, but you can set defaults or explicit field mappings, so saying, well, for this specific harmonized field, always use this specific DiSSCo field. Otherwise, we'll check against a list and say, well, we'll first check this field. If it's empty, we'll check the next one and the next one. And there's kind of order in there. But for now, let's focus on the machine annotation services. So these are the machine annotation services, and what they do is basically when I have a piece of code, I want to connect it with the DiSSCo platform and say, well, for this case, I have an ENA sequence linker. So I want to link specimen to ENA. I've written a piece of code, which in this case, just grabs a couple of fields from the specimen and then calls the ENA API and sees if we can get any positive matches there. And with these machine annotation services, you can register them in this orchestration portal. I have one ready for the API, and then I'll switch to more API stuff, as the front end still has some limitations, and I will show how it looks. So here I say to the orchestration service, well, I have a GBIF occurrence linker. I have this container image and this specific tag. And this is basically just a small piece of code, which I can also show. let's see, GBIF occurrence over here, which connects to Kafka. And this is a bit of boilerplate code. We're thinking of putting this in some library to ease the implementation a bit. And yeah, it gets the digital specimen from the message that it receives. It runs an API call. So in this case, we'll do a search with GBIF on the occurrence ID or on the catalog number and on the base of record. And when we get a result, we parse this result into an annotation. That's something we do here. Here we say we map it to an annotation of the type of an entity relationship. So we actually create an annotation with the entity relationship, and this is then a motivation is then we're adding new piece of information to the object. And this piece is of new information. The annotation is then sent back to Kafka queue so that the annotation processing service can pick it up, assign a handle to it, and persistently store it and index it. So basically, this is where all the stuff happens. It's really basic, but just to show how it works. And yeah, we added a couple of additional things, which is target digital object filters. So the GBIF one, we only want you to be able to run it on digital specimens. So where the FDO type, and this is actually the DOI of the digital specimen type. And we only want you to run it on things that are in topic discipline of anthropology, biology. But for geological specimen, you won't be able to run this service. So you can, with this JSON path annotation, you can very specifically say on which type of objects you want to run, be able to run this service. And then we have some additional metadata on what the state is in the repository. More advanced things like max replicas, how many can run at the same time. We still need to experiment those, but it should be possible to horizontally scale these. And batching permitted, that's something that we're working on at the moment to see if we can enable batches. So when I now post this, hopefully it works. It will now actually create, and that's why it takes a moment, it will actually create resources on the Kubernetes cluster that we have. So it will create, it's called the scale deployment of this machine annotation service based on the image and the information that's in here. And now in the front end, if we go to a specimen, for example, this one, we have actions, machine annotation service, and you can actually schedule the GBIF occurrence linker. So previously this was empty. And we have a couple of these. So this GBIF occurrence linker we just created, and it should also be visible here as well. If I reload this. The GBIF occurrence linker, and it now also has this handle attached to it. And we can now run and say, well, for example, I want the GBIF occurrence linker and I want the ENA sequence linker. And when we run it, it will actually put a message on a Kafka queue, and this Kafka queue will then start a machine annotation service. So at the moment, if we look in the namespace, there's no services running. So they basically scale back to 0. So when these machine annotation services are not requested, they scale back to 0. And when I request this service, well, you see now the first container is being created, and the second one is being created, and they're now both running. And in the background, you see something what we call a machine job record, which is basically a record of this job that has been running, has been created, and I'm hoping that soon we'll have that they're soon completed. You can have a look at the. So these have run, and then this one has started, which is the. And this just published or basically created received an annotation event and has generated a new identifier for the annotation as well. So we can see here that both of them have been completed. So now both machine annotation services have run over this object, have produced additional information as if possible. And now, I think I need to actually reload it here. We can see what the information was. If we say view the annotations, we can see that we have now two new linkages, two new objects of class annotation entity relationship to this digital specimen. And the first one is now a linkage to GBIF. So the entity relation type is now has GBIF ID. We still need to create some kind of ontology for this vocabulary. It has the IRI of GBIF where we can review it, and it also found an ENA accession number and an ENA number in there. And if we can also look at this as a JSON and then say give us the annotations, we'll see here that at this moment there's a first version of the motivation adding to this target, this specific type. The selector is a class selector because we added the class entity relationship with this value. The reference, this is basically the full ENA. ENA is a bit complex in that sense, but the full call that we made to ENA to gather this information. It also contains the creator, so the ENA sequence linker and the handle of the creator. So in this case, the machine, the software agent, and the software agent that generated the actual annotation, and of course when it was generated. And we can now also view them in the entity relationship tab, where we have this toggle for it. It says toggle annotations, but it says it should say toggle the entity relationship annotations. So the proposed entity relationships. And you see we have two links, and if we select this one, we'll actually go to GBIF, to the occurrence. This is the Campanula. Here it is. This is the GBIF record. And now we also have this ENA record, and it points to the, that's interesting. Well, we have to check the code for this one if it should run. This one, right? Yeah. Well, there might actually be an issue on ENA side, because I think we collect the right one. Because here it does say unverified of this object, so that looks good. But if we select it, then the page looks empty. So that might be an issue on the ENA side. So that's basically how these. And we have a couple more of these, test annotation services to georeference specimen or to, of course, for digital media, we can say, well, digital media, we're actually having a course issue here, which we're digging into. But, we can say, well, for this one, and you can now see that we only got the plant organ detection. So for the type of digital media object that actually have the specimen of the type botany, we'll also have a plant organ detection. We can also schedule this one, and again, the same thing will happen. That in the background this will trigger the service. You'll see that they will keep alive for about 5 minutes. So if they kicked off, they will keep being alive for about 5 minutes. And now this one is scaling down, so it's now terminating because it got no further requests to handle, and the other one is also scaling down. So this is the way that we try to get a flexible and scalable infrastructure. The plant organ detection is now scaling up. That's now running, so they will generate annotations, so that these annotation services will only be running when there's actual requests for them, and otherwise scale back to 0. I think that's the part on the machine annotation services I wanted to show. The machine job record, so that that's the one you see here. We created this one because one run of, and this one is actually a good example. So the plant organ detection. The plant organ detection could create up to 10, 20, or even more annotations because it searches for this region of interest for the threads. And we still wanted to be able to gather them, and we wanted to be able to give the users some feedback on when it would be completed. So one machine job record could contain multiple annotations that were all generated by the specific run of that specific machine annotation service with that specific version. Because of course, when there's a new image or a new update of the machine annotation service, it will generate a new version. So this is all connected to that specific version. Yeah, so we added this part. And here we can also view the annotations. Let's see. We still got some state issues on the front end, a couple of things. View the annotations, and here you see the plant organ detection, and it's adding in a region of interest with the class leaf, etc. And this is shown. So this is basically the same annotations with the bottom and core region of interest. So within this region, we found a leaf with a certain score. And this references, in this case, the GitHub where the model is. Might need to update this. Yeah, and you see also when and the handle of the machine annotation service there. Back to the presentation. Yeah, so we added the machine job records as well. Another thing that we're working on has been creating, one of the goals was to make a taxonomic range resolution service, because for most of the specimen, probably this one as well, we only have, in this case, we have a kingdom and a family in a genus, so that's actually more than we often have. But we don't have a full taxonomy. And we also want a link to a catalog of life. And we basically want this information when we ingest the specimen. So when the specimen comes in, within the ingestion process, we want to have the taxonomic name resolution as part of the harmonization of the specimen. And what this means is that the performance in that part is really really tricky. In the case that we want to be able to process a couple hundred specimens per second, and then calling a catalog of life or GBIF API would just result in a lot of traffic, a lot of TCP overhead, and just would slow us down by too much. We'll probably slow down to 3 or 4 specimens a second. So we were kind of thinking on how we could speed this process up, and part was to see if we can create an internal index based on the ChecklistBank data and have a name resolution based on the GBIF matching algorithm. So by combining those two things, I think I have some image here. I think here. By combining those two things, you can actually quite easily make a name resolution service. And we created it to make it a generic name resolution service. So when the service starts up, it will actually be an option to say, well, get a specific data set from ChecklistBank, which is requested in the called data package. Then index that called data package, that taxonomic data set, into a Lucene index. That's what we use, and an internal index, and then run name resolution APIs on top of it. So it's basically, that's the generic package. We containerized it, so we have a small container where you can indicate I want to have an internal index with the name matching algorithms that the GBIF is using on top of this specific ChecklistBank dataset. I have one running. See, yeah. So and the actual code is also at startup. It will make a call and request the call data package from ChecklistBank, get it in, index it, and start the APIs. And that's the generic setup. For DiSSCo, we will fork it and make a specific setup where we included Kafka. We did some first experiments, and we now see that we can make about 200-300 name resolutions a second, and we can also horizontally scale this upwards to. So we'll probably reach 500 or 600 a second should be doable, which is about I think where we'll probably land. So here I have the code. So I had a preloaded. You can also use a preloaded index of the catalog of life, and I can now have it open here. Yeah, it would be good to have this separately. I can now do a matching and then say, well, match, and say, if we stick to this specimen, I can now pick this name, which is just a scientific name of this specimen, and throw this name into the API, and it will give me the full information, the full taxonomic information from catalog of life. So we'll have the core ID, we'll have the scientific name, the authorship, rank, and then all classification based from the catalog of life. And we're hoping that if catalog of life provides the extended catalog of life, which GBIF is also planning to use as their backbone, or have the same matching algorithm and the same taxonomic information that's been used in GBIF as well, so that we align with GBIF, but still have all the taxonomic information within our system. We did this for the test environment. Let's see, I think I have it here. And there you can see that for the, I used this specimen for the buteo. We now, if we look in the JSON, have the full taxon identification in the sense that we have a taxonomic identifier to, which is the catalog of life ID. We have the full scientific name. We added the scientific name HTML label. I'm not sure if it will stay, but there's some magic in creating these HTML labels, which we took over from ChecklistBank. The authorship, species, and then the full taxonomic identifications. And we also included a link to catalog of life, saying, well, this is the link to catalog of life, and you'll get more information, and then see where catalog of life got its information from, which is the integrated taxonomic information service. So yeah, the first step is creating this generic service. It also got an autocomplete endpoint, which we'll probably also use when people want to add new identifications to it. Yeah, it's alphabetical, so in this case we'll get the data. And this is all based on an internal API, which we will run, so we won't, if we're doing hundreds of seconds, we won't, create a kind of DOS attack on the ChecklistBank APIs, but we'll just can process it internally, have all the load internally, and if something goes wrong, we won't pull down any external infrastructures. Yeah, so we're hoping to get this in place. I think my pull request actually needs to get reviewed by Sue on this part, and then have it completely integrated in the ingestion, then run it for a while in the test environment, and then move it to acceptance environment. I think before the next demo. It's really generic in setup, so also at least within Naturalis, we know there's interest in running an internal fast taxonomic name resolution index. So we'll discuss with them as well, and we're also trying to discuss this with catalog of life as well, and see if they could are interested in taking this generic service over, because it would help them a lot as well. Yeah, so some discussions with ChecklistBank and GBIF will probably have there as well. Something completely different. We got new icons for the topic disciplines and icons for specimen. And that's most fun in the dev environment, where we actually included the taxonomy for a couple thousand specimens. The loading is still an issue, so I'll need to fix that. But if we select something, it reloads, and then you'll see all these nice icons. With the specimen, I don't know if it will stay, but it's just to give the user a bit of an idea of what the specimen could look like. We use this website for it, PhyloPic, which provides, well, now approaching 9,000 silhouette images. You can also upload your own. Yeah, and the other one is that we have this topic discipline. These icons have also been updated. These are so a bit higher level in disciplines. DataCite. So one of the things we want to have in MVP is, of course, DOIs, very important. So we have some discussions with DataCite, and we moved through a couple of solutions actually. So this one, where we basically created this within Bicycle, is our own local handle server and our own local handle storage behind it, and this actually works really well. It's really fast and looks really good. But you know, DiSSCo doesn't want to be in RA. This is our own registration agency for DOI. So then we did a pilot where instead of storing them ourselves, we would call the DataCite API and have DataCite store the handles and have the local handle server and all the other stuff. But again, the overhead in the DataCite API calls, it's just large for the ingestion process. So here again, we were stuck at, I think, 3 or 4 DOIs that we comment per second. And then if you look at the ingestion of, let's say, a botany data set from Naturalis, I know it's I think 6 million items. If we can only process those at 4 a second, then yeah, that's just not working for us. And the other issue with DataCite was that they couldn't put more information in the DOI kernel, so in the FDO record. And that's one of the goals, and one of the ways in which we can make it machine accessible is get more metadata into the identifier itself, basically. So we're now proposing a new solution, and we're discussing this with DataCite next week. They are already formed, where we would still run the handle manager and the handle storage ourselves, and also run our own local handle server. So this will all be internal in DiSSCo, and that way we can still keep the performance. But at least for until DataCite can handle this load, we'll asynchronously push our information to the DataCite API. So this will be slower, but because we have this queuing mechanism by which we can make it asynchronously, it doesn't matter that will take a couple of days before DataCite is actually in sync again. So we get a kind of eventual consistency with DataCite. And we would be hosting the local handle server and the storage behind it for DataCite. So we get a kind of a construction that we would actually kind of host part of the DataCite infrastructure within our own infrastructure for performance reasons. And the idea is that DataCite in the long run really wants to be able to handle this kind of ingestion, and also be able to handle the additional identity information, the identifier attributes, the kernel attributes, but that might take a while before they're there. It will require significant changes in the infrastructure and architecture that they currently have. So yeah, this discussion is ongoing. And hopefully by next time we do a demo, we can either demo how this works or have some other solution for the minting of DOIs. Yeah, and then quickly for TETTRIs Marketplace, yeah, Tom is making some mock-ups on the TETTRIs Marketplace, so this will be developed within the DiSSCo team. And what it will do is we'll use most of the components of the DiSSCo infrastructure as well, but the marketplace for taxonomic services. And will just be a front end and an API, and we'll register handles for the services. We'll store them in our infrastructure and also connect to the DiSSCo AI. So it's more or less the same setup, and will be kind of objects, FDO objects within the broader infrastructures as well. Well, those are the things that we did. Well, we're also working on a plan for the CETAF DiSSCo collection registry. We have created a plan, and we need to discuss it with CETAF probably next week as well. Yeah, and see how we can move the collection registry forward, because we do want to make a collection registry, and if possible connect it as a master source within GeoCycle. But there needs to be some more discussion ahead on how and who and it will be developed. So we have a plan in place, and we'll need to discuss with CETAF on what the next steps are. Yeah, hopefully I can show it more in the next session. Yeah, looking forward some quickly, so we'll still have some time for discussions. Yeah, minting DOIs with DataCite. Hopefully we get that plan on the way, and next week we can hammer down some things. Integrate the taxonomic name resolution service, which I already showed, into the ingestion process. Most of the things are ready already, but they're still in pull request or on test environment. So hopefully next time we can roll those out on the acceptance environment. We're working on batch annotations for machine annotation services. Specifically says version 1, because we have hit a lot of issues here and a lot of bumps, because it's much more complex than we would actually think, and it will require additional information from the machine annotation services. So we will make them a bit more complex, but it will create the possibility to say, if I geo-reference, if the machine annotation service geo-references a certain locality string, that all specimens with the same locality string will get the same annotations. That's basically the same idea. So that you don't have to rerun the same machine annotation service over all specimen, but if you geo-reference one of them, if you link one person to a wiki identifier, that you will be able to say, I want all specimen with the same person. I also want to link that person to the Wikidata identifier. But a lot of issues there and a lot of hooks. So hopefully we can show this. Landing pages. So we have handles for the source system, mappings, and machine annotation service, but we don't have public landing pages for them yet. So this is something we're working on additional filter options. I think we got about 4 or 5 additional filter options in the pipeline, and then a bit more complex searches for taxonomy as well. So that you can actually walk through the taxonomic tree. Scheduling and automatic triggering of the translator service, which is basically the ingestion process based on the cron, so that automatically each week the ingestion will run again, and you can in between schedule an additional run of the ingestion process. Yeah, I need to update the miscalculation to the latest version. So there's been some developments, so we need to update those. We have virtual collections on the roll, which a virtual collection is basically kind of a stored search. So this is a mutable collection, that's important to mention. And will also be a first version to see how we can create collections, virtual collections within DiSSCo. So it will be, if you make a specific selection, you can say, well, I want to store this specific selection, and we'll generate a handle for it and some metadata. And you will be able to share this collection, but it will really be a first version as well. And then we have some infrastructure changes before we actually want to go to production. We want a centralized long-end monitoring solution. We tried a couple of things already, but slowly landing on one. And then we need to implement it on test and acceptance and get it in infrastructure as code and the whole thing. And yeah, all the individual deployments are scaling, but the cluster as a whole isn't scaling yet. So that's something we also want to get in place. So automatic scaling of like the EC2 instances behind the Kubernetes plane. We want to use Carpenter for it. Some additional resources of the things I've shown today. So the data models, and we have something called the DiSSCo developer documentation with some of the things that we use. The demo enrichment services contain the code of the machine annotation services I showed. And of course, we're still mostly in line with the deliverable 6.2, the construction plan for the core architecture. We've made some changes, but actually not that much. And we got more architectural documents and also requests for comments, which is basically the how the FEO types should look like, and FEO profiles, and the architectural documents contains like the architectural diagrams I showed. We could actually discuss in how we could open this documentation up more. Yeah, so I think 10 minutes, almost 10 minutes for discussion. So, well, a couple of things that came up in my head were what information is needed for the other task, and what would you like to see? Are there any specific functionality we're missing that should be on the roadmap? And how could we improve the dissemination of this information? So I think, yeah, we'll stop here, and then we can have a look at these questions. Are there any questions regarding the presentation on the machine annotation services, or how they work? Or
I have one. So is there a specification somewhere of how those annotation services should work? And can this be both per specimen, like the typical ones you showed, but also with working with data dumps, like the catalog of life one you showed? Is there a specification for that sort of setup? Because I can imagine that there's other services that would want to work with a dump and not do everything with API calls.
Yeah, that's a good question. I think at the moment we're mostly at the first, where you select a digital specimen and then run the service over it. Yeah, at the machine annotation service, well, let's go one step back. So the specification, I think we're now nearing a moment where we can say, well, we can write this down in documentation and it doesn't change every 2 or 3 weeks. So yeah, I think that's one of the things that we need to do, and yeah, at least write the specification what is needed to include the machine annotation service, how can you hook it in, and then it's a bit open in what the machine. So we've set up a first idea on how we could do it. And I think that works quite well at the moment, but that's only services that we develop. And now we need to see what will happen if other people develop services and what their needs are. So we've made this assumption that the image is publicly available, but it could be that it is in a private repository, the image, or it could be that that something else is going on, or maybe that it takes really quite a long time before responses gets back. It depends a bit on what the machine annotation service needs. So, and that's, I think also that's the probably answer to the second question, is like, if certain machine annotation services do need specific data dumps and have that locally in the environment, then we could see how we could include it. We could probably run it as well, like the catalog of life as well. But it will, we probably need to discuss it with the machine annotation service provider. Like, what do you need, and how can we provide this? I know we also got questions if we would be hosting. So if you get really GPU heavy AI services in there, would DiSSCo be hosting the tooling as well? And that's also still a bit up in the air. It might depend on the cost that it runs. And yeah, I think the first setup is there, and now we just need to see which direction it takes, and that also depends a bit on the requirements of the service providers. Yeah, and of the possibilities of DiSSCo as well, in the sense of financial. The financial part, yeah. Is that question? Does that answer it a bit, Matthias?
Yeah. I mean, there's still lots of stuff to talk about there, but we don't need to discuss everything here. I'm talking about this in the light of the annotation services developed in Bicycle last year, which have this basically start working with data dumps and with massive amounts of data from various specimens. So it's a completely different approach from the start, from the digital specimen one. So that's why I'm interested in how that could be integrated. But yeah, I understand that this is still the development stage, so all the documentation and implementing other ones is going to come later. So we can discuss that later on.
I do think that also with the data models, so when I said, well, we're going to make them public because the annotation model is now more or less fixed. We might add a property here or there, that we might make small changes, and the same for OpenDS. We might make small changes still, so I won't say it's a final first version yet, but yeah, enough stable to publish it. And we are looking for people to start experimenting with the machine annotation service as well. So we'll create some more documentation. I think we have a bit of documentation, but we need to create more kind of path on how you could develop a machine annotation service and integrate it.
Yes, something else. So the proposed system to synchronize with DataCite, I guess then you bulk push the handles that you want to mint there, or does it still scale at the more or less four specimens a second?
Yeah. So, but in the handle of the DOI would be minted because we would add it to our own handle server, which we would be running in our own environment. Only DataCite has their own registry, the DataCite registry, which and that would be updated later. So we have an asynchronous process, which would, because DataCite can only do a single DOI creation at a time, let's say. So yeah, we would do it in bulk and process it really fast, and they would be exposed as well and resolvable. But the DataCite internal registry would be updated later at the 4 second rate. Yeah, because they're just not capable of handling a larger volume faster.
Because if I did some quick math, so it might be incorrect, but if my math is correct, and doing that for 6 million would take about 17 days at the DataCite rate. So that's going to be a problem. Yeah,
but so, and the solution we currently have, because this is precisely the discussion that we have been having with them as well. Yeah, I did the math as well for the data set. So now the DOIs would be resolvable. They would be in DiSSCo. They would just not be, if you would, I think DataCite have their own search functionality as well there and index it as well. They would not be findable within DataCite. Yeah.
If you go to like search.datacite.org, that's the index.
So yeah, that would take up to 70 days before they would be findable within the DataCite repositories. Yeah.
But the DOI will be working.
Yeah, the DOI would be working and be resolvable. Yeah. So that's now the solution. We are saying short-term solution because in the end, DataCite does want to be able to do the bulk processing and have the full FDO record in there as well. So that it also pushes them a bit towards more FDO compliant solution. Was it useful?
Yeah.
Okay.
Yeah, it was super interesting. Thanks.
Yeah, super. Last question. Sorry, maybe we're a bit over time then. Could you give me a bit more detail about how you do the orchestration? As far as I remember, what I got from it, I mean, you spawn the annotation services, so to say, on demand of a particular object. And then they are kept alive for a 5-minute span, meaning a concurrent user could start also a service requesting a similar a similar functionality, although a similar, how do you call it, microservice also, which provides such an annotation. And in this case, you reset the counter and it is processed also. Or how do you scale this?
So the backend would put a message in the queue. So let's take one step back. So if you put them into the orchestration service, you'll get the scalable deployment, which puts scale basically down to 0, and it will deploy a queue, a Kafka topic, it's called, but it's basically a queuing mechanism. And when the user selects a certain machine annotation service, it will put a message on the queue. It will basically put the OpenDS of that specimen, will put it on the queue. And if another user does it for the same machine annotation service for another specimen, we'll also put that specimen on the queue, and etc.
Okay.
And the deployment will basically watch the queue. It's called with the tool called CETAF, Kubernetes Event-Driven Architecture. It will kind of pull the queue, and when it sees, well, there is a message on my queue, then it will start an instance. And that will take all the messages from the queue, and if the queue is empty, it waits a couple of minutes and then scales back to 0. So if you have a lot of, so if I do the request for machine annotation service as well as completely empty, it takes like, let's say 2 minutes to start up this process, and it takes a while. But if it's warm, because it's still running because some other user requested it, it goes faster.
Okay.
Yeah, then you get a kind of immediate response because it's already running. And you can also scale horizontally scale based on the queues. If you say, well, there are now really a lot of messages in this queue, then you could also say, well, give me 3 or 4 or 5 instances of this machine annotation service, and they can all run in parallel. So that is an option. You can also select how
that
many.
He spawns more of these containers, of course, of the same type. He makes more instances. Just okay. Yeah, cool.
Yeah. And then basically the same process we do again with the annotation. So it produces an annotations which we will put on a queue, which will be processed by the annotation processing service. And then the idea is that we can really scale up and down, really flexible based on the actual usage of it. So I think if it's completely scaled down, you can almost run the DiSSCo infrastructure on your laptop. I think you can, I need to try it once, but it basically on a 60 gig couple CPU laptop, you can almost run the entire infrastructure. Unless it's completely scaled up, then you'll have issues. Yeah. So I think maybe, I think we actually run it on 2 EC2 instances, 2 small EC2 instances. Yeah. So that's the philosophy behind it.
Okay, super. Yeah, people start to jump out of this because, I mean, probably many have follow-up meetings. I think there is also a DiSSCo board meeting later. I will stop the recording now.